Welcome to this video. In here we're going to do a no-cards review of Chapter 5, Calculus BC. Let's jump right in. First, log integration. Long division is a very useful way to do this thing, so pay attention to that. An example will be, take a look at this integration right here, like integral. So the integral of x squared plus x plus 1 all over x squared plus 1 dx, this one, because the denominator and numerator has the same power, this is a hint for us to use long division. Because whenever numerator is greater than or equal to the denominator's degree, we can use long division. So remember long division, this is the steps, the process to do it. Ultimately, we get 1 plus x over x squared plus 1. Then we can plug this answer back into our integral. And then everything becomes a lot more easier. We can break this down into two integrals. For the first integral, the antiderivative of 1 is just x. For the second one, we will use u substitution. Let u be equal to x squared plus 1. Du will be 2x dx. And then 1/2 du is x dx. Notice that x dx can be replaced directly. So we only left with 1 over u du, but don't forget the 1/2 in front. Ultimately, we can solve this by taking the antiderivative of this 1 over u, which is natural log of absolute value of x squared plus 1. Moving on to derivative of an inverse. G prime of x is equal to 1 over f prime of x of f prime of g of x. What is taking the derivative of a constant raised to the x power? It will be a to the x times natural log of a, so natural log of that constant. This is good to memorize. How about taking the derivative of a constant raised to a function? You will get a constant raised to that function times natural log of that constant times the derivative of that function. How about antiderivative of a to the x dx? You will get a to the x over natural log of a plus c. Notice that this is just the opposite process with how we take the derivative of a to the x. Moving on to derivatives of arctrig. So those are also some special formulas that is good to memorize. Taking the derivative of arc sine u will give us u prime over square root of 1 minus u squared. The derivative of arc secant u will be u prime over the square root of u times the absolute value of u times the square root of u squared minus 1. The derivative of arctan u will be u prime over 1 plus u squared. The derivative of arc cosine x will be negative u prime over square root of 1 minus u squared. Notice that the magnitude is exactly the same for arc sine u. The only difference is the sign, so it changes to negative instead of positive. Same as arc cotan u. This is the same as arctan u in magnitude, but just adding a negative right here. Arc cosecant u is the same thing as arc secant u in magnitude, but adding a negative sign. Inverse trig integration. So taking the integral of 1 over square root of a squared minus u squared du will give you arc sine u over a plus c. Taking the integral of 1 over a squared plus u squared du will give you 1 over a times arctan u over a plus c. Taking the integral of 1 over u times square root of u squared minus a squared du will give you 1 over a times arc secant square root of u over a plus c. And that's it for this quick little review of Chapter 5, all of the important formulas and key terms for you to memorize. Hope that helps.